Hi, darling.
Hi,
Hi,
darling.
Sierra.
Hi, Sierra.
You guys are creeps. All right, so here we
Now
go.
you have to use this recording.
I might. Okay, let's do, what page is this? 12. Let's go to page 12, okay? Do you guys remember piecewise functions? Do you guys remember how to graph a piecewise function? Yeah, you got to go to the lobster. Here, I'll show you. I mean, you're not graphing this piecewise function, but just so you know. Oh, my fingers are too fast. All right, there we go. So in a graph page, you're going to go to the lobster, and then do you see these brackets with several boxes? It starts like here. This would be for two pieces with two inequalities, three pieces with three inequalities. And then there is, I think if you go on this one, you can also adjust it if you need more pieces than that. You can change the number. So that's how you graph a piecewise function. And then you can also look at them and generate their equations or talk about their limits. So write the equation of the piecewise function f of x below, then answer the limit questions. Okay, so how would we write the equation of a piecewise function? Well, first, what is this guy's name? He's f of x, right? And then we've got a bracket. How many pieces are here? 3. Good job. It looks like just 2, but there's a dot, right? So let's read from left to right, okay? This guy starts at what x value? -3. Are we including -3 or not? Yes, it's filled in, right? Then we're scrolling along the x-axis, so we're going to put x as our variable in the middle of the inequality. And then I'm going to keep going. And where does this particular piece that Bertram is walking on, where does it end? 3, right? Are we including 3? No. Right, good job. So that was the first piece done. Let's write its equation. What is this? It's just a horizontal line, so it would be what?
Y = y.
Yep, except you have your y equals already from the f of x, so you would just write 1. Okay. Next piece. The next piece is just going to be this little dot right here, okay? At 3. So we would say x equals 3. What is the y output? 2. Oh, my bracket is not large enough. Here we go. And then for the third piece, what x value are we starting at? 3, right? Are we including 3 in this piece? No. And then where are we ending? Yay. So we would just, instead of going like this, that's not really mathematically correct, right? We would just say x is greater than 3. Okay, so if you encounter that, just change your inequality. Go back. What is this piece? Well, he's a linear function, right? Let's find the slope between 2 points. Down 2 over 2, right? So that's going to be a slope of -1. And then what's the y-intercept going to be? What do you guys think?
6, 7, 6.
What do you guys think? 6 or 7? 6? Okay, let's double check, right? So I've got -x plus b. And then let's put in a point. What point should we put in? 5, 0 maybe? Yeah? Wait a second. 5, 0. It's not a point on the graph. Hi there. How you doing? It is 5, 1. All right. So we've got y equals -x plus 6. Okay. All right. Do you guys see how to write an equation of a piecewise function? Why do you think it's lumped into the, what's it called? Piecewise function, or the limits unit? What do you think?
Wait, well,
What's the question?
Why? That's a good question. Why do you think piecewise functions are lumped into the units, the limit unit?
Because there's limits in a piecewise function.
Yeah, right? Those funky graphs that we're examining, the limit from the left and the limit from the right, they come from piecewise functions, okay? So, yeah. Oop. All right. So, let's examine the limit as x approaches 3 from the right. What is it? Bertram, where are you at? Da, 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 da. What's the y? It's coming in. It's 3. What's the limit as x approaches 3 in total? That means you have to examine the limit from the left and the limit from the right. It does not exist. And you have to write the reasoning why. The limit as x approaches 3 from the left of f of x is not equal to the limit as x approaches 3 from the right of f of x. Therefore, the limit as x approaches 3 holistically of f of x does not exist. Okay. So if you learned a cool new language that you can scare your friends with, right? What? These are our friends. No new friends. My friends are in this room. So what about the limit as x approaches infinity? Where's Bertram headed? Where's he going?
He's going down.
He's going down, negative infinity. Okay. Cool.
Wait.
Yeah. Okay, example number 2. Now think about absolute value functions. What does it look like? Do you guys remember? Yeah. So think about it like this, right? Couldn't you rewrite that as a piecewise function if you wanted to?
Sure.
You could, right? So I'm just trying to get you guys to think about both sides of an x value, okay? So you wouldn't really need to generate these on like the IB exam or anything. It's kind of just a way for you to better understand. So as we come in from the left, right, what x value are we going to be kind of changing direction or starting a new piece? What x value? 0, right? Okay, so all the way to the left of 0 would be considered what? X is less than 0, right? What would the equation of that line be? Just negative x. It's just a downward facing line, right? Then 0 is defined in the function. You just have to pick which piece you want to put it in. It doesn't really matter. It's your choice. So I'm going to put in the second piece just because x is greater than or equal to 0. And then the equation would just be a positive x.
Do you just pick one to be included?
Yep, just literally doesn't matter. So now we also have some cousins who are closely related to f of x equals the absolute value of x. So take, for example, something that looks like the absolute value of x over x. Let us investigate, okay? So before I let you guys break away and think about this together with your group, or partner, whatever, let's take a look at what this looks like. So think about it. Before I graph it, right? I've got an absolute value on top. That means the top is always what? Positive, right? And I'm putting an x into it, right? So if I said maybe, actually I would like to show you this first before we look at the graph. So if I have f of x equals the absolute value of x over x, and I want to make a little chart. Do you remember these where you're like, okay, -2, -1, 0, 1, 2, right? You just want to kind of get an idea of what this graph looks like. So I take a -2 and I put it in there. What happens? The top is always going to be positive, and then what happens to the bottom? He maintains his negativity, so he's going to be -1, right? Okay. What about f of -1? Same thing happens, right? Absolute value of -1, he becomes +1. So you always have an equal magnitude in the degree and the denominator, right? So you're always going to get some version of 1 if there's no coefficients or transformations or anything like that, right? So I've got -1 up here, and then I got a -1 down here. He's going to become a +1, -1. What is your answer going to be? Positive and a negative, -1. So then what about at 0? You're dividing by 0, so what's going to happen there?
It's going to be 0.
Undefined, okay? Actually, let's be mathematic. Undefined. A hole with a sad face. Okay, so now let's put in f of 1. You're going to have the absolute value of 1 over 1. So what's going to happen for these guys? They're going to be what? Equal quantities in the numerator and the denominator, and they're both positive, so it's always going to be +1, okay? So this graph actually looks like, what do you think? Just a horizontal line, y equals -1, until we get to where? 0, and then we jump.
Wow.
Okay? And then now what you're going to do is play with the transformations down here and see how it affects the sketch of the graph. So what you're going to do is you're going to take a guess at what the graph looks like without graphing it, right? So think about what kind of quantities are going to be up top, what kind of quantities are going to be up on the bottom, when are they going to be positive or negative. Then you're going to write the absolute value equation as a piecewise function, and then you're going to graph them on your calculator. You might want to look at the calculator first before you make the piecewise function, and then your sketch doesn't have to be perfect. You're just kind of showing what's happening, okay? Because once you outline all of that, you're going to answer these quick little questions about the two-sided limits from the functions that you examined, right? So let's do one together, and then you guys can do them apart, okay? So J. Oh, no, that's an I. Hey there. Okay, so I'm going to do, I don't know, -2, -1, 0, 1, 2. All right, so -2. If I plug a -2 in, right? -2 minus 2 is going to give me -4. -2 down here is going to give me -4, so it's going to be a positive over a negative, and what is that going to end up being? -1. All right, let's try the next one. -1 minus 2 over -1 minus 2. That's going to give me -3. -1 minus 2 is going to give me -3, but it's an absolute value. So it's going to be +3 over -3. This one's going to be negative. What's going to happen at 0? -2 over -2. So you're going to have +2 over -2. This one's going to be -1. Okay. And then 1, I'm going to have 1 minus 2. It's going to be -1 over 1 minus 2 is going to be -1. So it's going to be +1 over -1. What's that going to be? Hang on a second. What's happening? Why should I add one more x value down here?
It hasn't changed.
It hasn't turned yet. Where is the turn happening, and how do you know? The turn's happening at 2. How do you know? Look at the function, right? You took the original one that you just worked with up top, and you shifted it right 2. Because look at the transformations in there, right? Yeah. So now I got 2 is giving me a 0. So now here's my problem. Here's my jump from the negative line to the positive line. And now I've got 3 minus 2 over 3 minus 2. It's going to be 1 over 1. So now we get into the positives, okay? Then you're going to take your little sketch. You're like, oh, okay, I was going through the numbers, and I saw that I'm at -1 until I get to 2, right? And then at 2, there's going to be a jump, and then I'm going to switch to 1. So that's all you need for your sketch, okay? So it says write the equation as a piecewise function, and then we'll have to take a look at the graph and edit our sketch. So we're going to have I of x. Hello? What?
I do not remember this.
So we've got, I don't know, a horizontal line from -infinity to 2. So I'm going to write when x is less than 2. And then I have a +1 as my equation when x is greater than 2. All right? So that's all you got to do. Now check your sketch. Does it look right? Yay, it looks good. Okay, so that's what you're going to do for a G, H, J, K. Answer the questions, and then I really hope we get to pass the problem, but it is a Friday day. For 3, actually I should show you 3 too, and then you guys can work on the absolute value ones. So for 3, this is on the next page. It says the key to finding the limits of piecewise function is to always make a sketch first. That's why your homework is called one-sided limits are sketchy. I'm so funny. So you always want to draw the sketch first because it just like shows you immediately what you have that you're working with. You can base your sketch off of graphing the piecewise function on your TI first if you want. Just make sure you still draw the sketch because that's how you build your understanding of what's going on. So f of x is equal to x minus 1 when x is less than or equal to 3. Okay, so I've got my little graph here. x minus 1. So that's going to look like -1, and then he's just going to be going up like this, okay? And it's going to go all the way up to what value? There's a problem at 3, right? And then we are including 3 in the first piece, okay? And then for the next one, let's see what's happening right at 3, right? So if I evaluated this guy, let's do 3 onward for the second piece. The first piece we already know how to do from our head. So for the second piece, we got 6 minus 7. That's going to give me -1. Let's get maybe 1 or 2 more points. That's going to give me 12 minus 7. And then I'm going to do 5. That'll be 15 minus 7. Okay, so that's what the next part of the graph is going to look like. So it's going to be a linear function. Are we meeting at 3? Think about your discontinuity. Are you guys meeting at 3? Let's start the thing here. Are we meeting at 3? No, right? There's going to be a jump, okay? And then we have a pretty steep slope with a y-intercept of 7, so I can just kind of do that. It doesn't have to be perfect. It would be way steeper than that.
Apologies for the interruption, but any students who are going on the Makeup Waboko field trip this morning, please make sure to come down to the lobby immediately. Thank
A
you.
makeup field trip. Anyway. So the limit as x approaches 3 from the left. What is that going to end up being? Well, let's figure out what 3 looks like on the function from the left. So from the left means I'm looking at the left piece. Oh, sorry, I should color code it. I'm looking at the left piece here, and then this is the right piece. He's the green piece, okay? So from the left means I'm going to be looking at the black piece, okay? So let's plug in a 3. 3 minus 1, what do we get? 2. So the limit as x approaches 3 from the left of this guy is going to be 2. Now let's look at the limit as x approaches 3 from the right. From the right. That means I'm going to go to the right piece here. I'm going to evaluate the function at 3. I already did because I needed it for my table, and I end up getting -1. Therefore, the limit as x approaches 3 in total, what is that going to look like? Yep. And then we would say the limit as x approaches 3 from the left of f of x is not equal to the limit as x approaches 3 from the right of f of x. Okay, so go ahead and finish up those problems with the absolute value and the sketching and the two-sided limits. It's very useful for you to see what's going on. And I'll be around to help you if you need it. I'm also going to check your homework.